Okay, happy Friday. So we've talked about factoring. Hopefully we're getting comfortable with complex factoring and simple factoring. We need to talk about the two special cases that you'll run into. One in particular that doesn't always look like a regular trinomial, so it doesn't always look factorable, but it is. And the two cases are difference of squares, which you may remember from last year. So difference of squares and perfect squares. And I'll give you an example of each. So a difference of squares trinomial is one in which we start out with factors that have the same terms, except the second term in each bracket, in each binomial, is the different sign, is a negative sign. So let's say I have x plus 3 in this bracket. This bracket will be x minus 3. And if we distribute this, even though it is a trinomial, something really weird happens. So if I multiply the x by the x, so I'm just going to distribute these two brackets. So we end up with x squared, and then x times negative 3, so I get negative 3x. And then 3 times x, I get positive 3x. And then 3 times 3, I get negative 9. And my final step is always to simplify. And when I simplify this, I'm going to notice that this negative 3x and this positive 3x are like terms, but they're opposites of each other. So when I put them together, when I find the sum of negative 3x and positive 3x, I end up with a term of 0x minus 9. And if I write it like this, it's obvious that it's a trinomial because it has that center term. But if we were to simplify this properly and write it using proper math form, we don't write a 0x because 0 times x is just 0. So we eliminate it altogether, and we end up with a term that looks like a binomial, but it's actually a trinomial quadratic where the middle term is 0. We call this a difference of squares. And in order to recognize the difference of squares, we need to understand what the trinomial is going to look like. And if we always start out with two binomials that are the same, except for the fact that the signs within the binomial is different, we always end up with a trinomial where the middle term is missing. However, it has very specific characteristics. The first is that it's always a subtraction. So there'll always be a subtraction here. Because if this term is negative or positive and this term is negative, if we multiply them together, the product always has to be a negative. So if we are going to eliminate that middle term, we know that the C value always has to be negative because these have to be opposite signs, and for them to be opposite signs, and we multiply them together, opposite signs always end up with a product that is negative. So we always have to have a negative in here. The C value is always a perfect square. Or rather, the absolute value of the C value is a perfect square, because really this is technically negative 9, but if we talk about it in terms of absolute value, which means we remove the negative sign, it's always positive, it's a perfect square. The same with the first term. Even though there's nothing written in front of that x squared, we know that it's a 1, and a 1 is actually a perfect square, because both 1 and 9 can be square rooted into a whole number. The square root of 9 is 3, and the square root of 1 is 1. Okay. Let's do an example. Let's say that we have get rid of the bracket. I have an expression. The expression is 4x squared minus 100. Well, does this meet the criteria for being a trinomial? It doesn't have a middle term, but maybe, just maybe, it's a perfect, or it's a difference of squares trinomial. And if it is, I know that there's 3 characteristics I have to look for. This has to be negative, which it is. This has to be a perfect square, which it is. The square root of 4 is 2. And the absolute value of c has to be a perfect square, which it is. It's 10. So this checks out. This is a difference of squares, and I can factor this. And because I know it's a difference of squares, my factor rule is quite simple. I know that these 2 terms here have to be the square roots of this number because they'll multiply together to give me 4. So this has to be 2x and 2x, whoops. 2x, 2x. And I know that these values have to be the square root of the absolute value of negative 100, so the square root of 100, but one's going to be a positive and one's going to be a negative. So this is going to be plus 10, and if that's plus 10, this is going to be minus. And that's really it. That's all there is to difference of squares. Let's go back and let's talk about perfect squares. Perfect square trinomials. And I think my audio levels are pretty good. If there's anything wrong or there's feedback on the levels, please just let me know in the chat so I can fix it. Right. So perfect squares will be the factors will look something like this. And it's a case where the factors, the 2 binomial factors that we end up with, are actually exactly the same. So it's going to be something like this: x minus 4 squared. X minus 4 squared in expanded form is x minus 4 times x minus 4. These are exactly the same. Because the binomials are exactly the same, I should be able to recognize this when I distribute them into their trinomial. So x times x is going to be x squared. X times negative 4 is going to be negative 4x. Negative 4 times x is going to be negative 4x. And then negative 4 times negative 4 is going to be positive 16. There are a few characteristics that you'll always see amongst perfect square trinomials. And let's simplify this. So x squared minus 4x is going to be 8x plus 16. The first is that just the same as difference of squares, my a coefficient and my c coefficient have to be perfect squares. So they are perfect squares. Even though nothing's written here, we know that it's a 1, and the square root of 1 is 1, and the square root of 16 is 4. But there is something we have to look for in this middle term. And in order to know what the middle term is actually supposed to be, let's do this exact same thing, but let's do it with variables rather than numbers. So let's come down here. Let's take an example of a perfect square, but instead of something like 2x plus 4 squared, let's actually just make it all variables. So let's say that we have ax minus b, and let's make it plus squared. So I have the same binomial multiplied by itself. I'm going to expand this. So ax plus b times ax plus b. And then I want to distribute. So I'm going to get a times a, so a squared x. Ax times b is going to give me positive abx. And then b times ax is going to give me plus abx again. And then b times b is going to give me b squared. And when I simplify this, I get a squared x plus abx is 2 of those, so it's 2abx plus b squared. And if we get rid of the x's, just to simplify this a bit, just to look at the coefficients, I can see that this middle term is actually the square root of a times the square root of a, or sorry, the square root of a squared, which is a, times the square root of b squared, which is b, times 2. So it's 2 times the square root of a times the square root of b. So in order to check if something's a perfect square trinomial, I'm looking to see, okay, is the a coefficient a perfect square? It is. Is the b coefficient a perfect square? And it has to be positive, and it is. And is this middle term a sum, or rather a product of 2 times the root of a times the root of b? So the root of a is 1, the root of b is 4. 4 times 1 is 4, and times 2 we're given 8. It doesn't actually matter if it was positive or negative, because if it was positive, that just means that these 4s are positive, and if it's negative, that just means that these 2 4s were negative. All right, so let's do a couple examples. Let's do a difference of squares. So let's make it 9a squared minus 49. And then let's do a perfect square trinomial. So we'll have 25. Well, I'll make it simpler. We'll do 4m squared minus, and this has to be a perfect square too, so we'll say minus 25. And then this will have to be, I know that it's got to be the square root of a times the square root of b times 2. This is going to be 5, this is going to be times, this is going to be 2. 2 times 5 is 10, double that, so it's going to be plus or minus 20. So working these out, I'm going to recognize this as a difference of squares. I know this is a perfect square, that's a perfect square, and this is a negative, so this all checks out. And so I know that my 2 binomials are going to be 3a, because 3 is the square root of 9, and this is also going to be 3a. These 2 are going to be the same, except they're going to be opposite signs, and it's going to be the square root of 49, which is 7, 7. One's going to be positive, and one's going to be negative. For my perfect square trinomial, I know that it's going to be 2 identical brackets, so I'm actually going to write 1 bracket, and I'll just put a square root there. But just for the sake of teaching, I'm going to do the 2 brackets and combine them later. I know that these first terms are going to be the square root of 4, which is 2m, and these 2 last ones are going to be the square root of 5, which is positive 5. And I would combine those to write it in proper form, which is 2m plus 5 squared. And if I wanted to, I could do a check, and I could redistribute these to see if I get what I started with. I'm going to assume, for the sake of brevity, that you can do that on your own if you like, but it's a nice way to check to see if your answers are right on assessments. And that's it for today. It is Friday, so, you know, if you've done all the stuff from the modules this week, relax, take it easy. They are technically due on Sunday. So I'm going to try to get all your feedback from all the Google Forms that you did this week, and I'll email you all the results from that. And if you have any questions, let me know. And we'll do this again on Monday. Now, we just got approval to be able to do Google Hangouts, and Google Meets, and Microsoft Teams. I think we'll try, I'm not sure which platform we're going to try, but we'll try it on Monday, but it'll be more accessible. But that way you can at least come in, and instead of texting, you can come in and sort of ask questions as we go, because there's no delay for one, and it's a lot easier to get some audio questions rather than text questions, and you can even show me your questions through a whiteboard too. So I'll let you know. I'll post in the Google Classroom exactly what we're going to do and what I figure out. But enjoy the weekend, stay safe, and I'll see you guys soon. Bye.